we're going to use Cramer's rule for this little matrix multiplication. You would have sometimes seen that you will expand it out by multiplying these across, but Cramer's rule is a bit different. So Cramer's rule for, let's say, x is going to be the determinant of ax divided by the determinant of a. So I'm not going to work out the entire determinant for a 3 by 3 matrix. I've got an entire video on that. But if this is A and this is B, that means the determinant of A is 2. So that whole determinant is 2. So x would be the determinant of ax over determinant of A. Y would be the determinant of ay over the determinant of A. And z would be the determinant of az over the determinant of A. So ax would be, you take B and you replace the first column. So you're going to have determinant of x, which is 2a, 1, 1, 2b, 0, 1, 2c, 1, 0. So determinant of ax, again, this is a 3 by 3 matrix. I've got an entire video on how to find the determinant of a 3 by 3 matrix, but the determinant of ax would be minus 2a plus 2b plus 2c. You can check out, I've got an entire playlist itself just dealing with everything to do with this. So if you're unsure about that, probably click away and have a look at that. So then let's now do the determinant of ay. We do the exact same thing as we did here, but instead we replace this column in the second column. So you're now going to get 2a minus 2b plus 2c, and then you'll have the determinant of az, which is going to be 2a plus 2b minus 2c. We then apply Cramer's little rule here, divide all of these by the determinant a, which is 2, which means that all of our 2's will be cancelled out for each one. So therefore, we're going to have x equals minus a plus b plus c. Y would equal a minus b plus c. And z would equal a plus b minus c. And like that, we are done.